This video is going to look at another example looking at your definite integral, and we want to use once again the limit definition to evaluate the definite integral from 1 to 3 x squared dx. And here I have provided our formula for the limit definition. So we're going to take the limit once again as n approaches infinity, and the sum is going from I equals 1 to n, and we need to identify what is going to be the width, or in other words, we can think of this, what is the width, or what's going to be dx, what's this width of each of our rectangles going to be equal to. And remember, that's going to be b minus a over n, and keep in mind your lower limit here is a to b, so it's 1 to 3, so that means we would take 3 minus 1 over n, so we would end up with 2 over n for our dx here, or the delta x, and then we need to find the c sub I, and remember that's going to be your a, so in this case our a is 1 plus the delta x, which is 2 over n multiplied by I. And don't forget, we need to actually take this and substitute this into the function. So we want to find f of ci. So we're going to take all of this and substitute into the function here, which is x squared. So we would have 1 plus 2 over n I, the whole quantity squared. So if we fill this into the process, f of c sub I, we're going to have our 1 plus 2 over n times I quantity squared, and then all of this is going to be multiplied by the dx, or the width here, which is 2 over n. Now, to me, that may be your hardest part, which is basically just substituting in. And now we just have to simplify. And before we eliminate the summation here, it's probably best to simplify this a little bit. So first step is, before we can distribute the 2 over n, we need to multiply or square 1 plus 2 over ni. And when we square this, keep in mind that means we're going to actually have to FOIL. So we're not just going to square the 1 and the 2 over ni, but we have to write this down and FOIL this thing. And if we do that, we're going to get 1 times 1, which would be 1. And then we're going to get 1 times 2ni, and then when you FOIL it, you're actually going to get that again. So you're going to end up with 4 over ni. And then you're going to square the last term, so you would end up with 2 squared is 4 over n squared I squared. And then we still have the 2 over n. For example, I want to make sure everybody sees this. We're taking 1 plus 2 over n I, and we're going to multiply that times 1 plus 2 over n I. So most of you recall the FOIL method. We're going to multiply that out. So you can't just simply square each term to get the answer. All right, next we're going to distribute the 2 over n. We're going to distribute that to all 3 pieces, and doing so we're going to get 1 times 2 over n, so we have the, whoops, I left out our sum here. So for the summation here, we're still going to have, we left out the sum, so I want to plug the sum back in, so we still have I equals 1 to n as n goes to infinity. So once we distribute this, we're going to end up with 2 over n plus 8 over n squared I plus 8 over n cubed I squared. And now we're at the point where we can eliminate the summation by using the formulas. Now keep in mind here we have 2 over n. This is our constant. Here we have our I term, and then we have an I squared. So keep in mind the summation formula is the sum of a constant is simply equal to the constant times n. The sum of I is equal to n times n plus 1 over 2, and the sum of I squared is equal to n times n plus 1 times 2n plus 1, all divided by 6. So we're going to substitute all of those in, so we would end up with just the limit as n goes to infinity for 2 over n, so that's 2 over n multiplied by n plus 8 over n squared. So in place of the I, we're going to plug in n plus 1 over 2. And once again, I'm going to distribute, so we could simplify this to n squared plus n over 2 plus 8 over n cubed. And once again, here we have the I squared. So we're going to take this I squared, which is this whole formula, and we would have n times n plus 1 times 2n plus 1 all over 6. So therefore, using the formulas, keep in mind, therefore we are able to eliminate the summation. So now we're just looking at taking the limit as n goes to infinity, and at this point we're just going to simplify the expression to something that we can easily take the limit of. So of course here 2n over n, the n's are going to cancel, so we're left with 2 plus, here we distribute the 8, we have 8n squared plus 8n over n squared times 2 is 2n squared plus, and here we can do a little bit of simplification. We have the n, what would cancel, so this becomes n squared on the bottom. Okay, so this would become, maybe I can rewrite this, this becomes n squared. And at this point we can take and distribute the 8, or to make things easier we'll leave this as 8, and we can FOIL the n plus 1 and the 2n plus 1. So if we FOIL that, we're going to get n times 2n is 2n squared plus 1n and 2n becomes 3n, and 1 times 1 is plus 1. And all of this is still divided by the 6 and also the n squared that we have out front. All right, we're getting closer to a point where we can take the limit. We'll do one more simplification, I believe, and we'll be in good shape. So the 2 we can leave alone. This part, we can actually divide the 2 into the 8, and we would end up with 4n squared, and then the 2n, we would go end up with 2 into the 8, we would have 4n, and this is all over n squared. And over here we have the 8 that we can distribute across the top, and we would end up with 8 times 2 is 16n squared plus 24n plus 8 all over 6n squared. All right, now we're at a place where we can take the limit here. And if we take the limit, of course, of 2 as a constant, that would simply be equal to 2 because there's no n here. The next term here, we have the same exponent on top. So that means we can look at the ratio. In this case, the coefficient on the bottom is understood to be a 1. So we would have 4 over 1, so that's plus 4 over 1, plus, and the same thing happens here. We have an n squared and n squared on top. That's the largest exponent. So we take the ratio of the coefficients, 16 over 6. And if we add these all up, we will end up with 8 and 2/3 for our answer. So once again, that is the answer to this definite integral. If we were to integrate x squared dx from 1 to 3, once again we come up with a single number for our answer, which in this case is positive 8 and 2/3.